Hi. I was expecting to see some faces, but there's too much light. OK. I think it's best for me because I get less stressed. I don't see people. So I assume that it's only me in my room rehearsing. So before I start, I had to cut off some part of my presentation to just be able to fit it into the time slot that I had. So I just want to apologize for that. A little bit about me. My name is Negar Jamalifard. I'm a front-end dev at Lightspeed Commerce. I am based in Berlin, but I soon will be relocating to Montreal. You can find me on Twitter at negar.dev. And I love learning about new stuff. And I love to talk about them because it helps me understand them more deeply. So that's basically why I'm here. Today, I'm going to talk about CSS Houdini. I hope that you see. But the first part of my presentation is going to be a little bit of background information that I believe we need in order to understand how cool CSS Houdini is and why it is so important and so impressive. So we'll start with the background information part. How do browsers render CSS? Well, browsers are such a complex software. They have different parts with different responsibilities. And one of the really important parts of browsers are rendering engines. All of the browsers have their own rendering engine. For example, it is called Blink in Google Chrome and a couple of other browsers. It's called Gecko in Firefox and WebKit in Safari. They have their own rendering engine, but all of these rendering engines go through the same set of flow in order to, from the point that they receive an HTML, CSS file to the point that they can actually render something on the screen. And in a bit, in a few slides after, we're going to talk about this flow. So the first step of a rendering process is parsing. So when a browser receives an HTML file, first it will receive it as bytes. And then it will convert it to, based on the extension file that it knows it's an HTML file, so it will convert it into characters. And then since it cannot do much with characters, it will convert them into smaller, meaningful chunks named tokens, and then it will turn the tokens into JavaScript objects that we call nodes, that each object has all the information about each HTML tag. For example, the name of the tag, the attributes, and everything. And then, based on the parent-child relationship of these nodes, it will create a tree-like structure, a tree-like object model that we know as DOM. Well, DOM is not something unfamiliar for us, but what happens with CSS? Well, whenever rendering engine in a HTML file encounters a link to a CSS file, it will download the CSS file in the background and then go through the same process. It will turn bytes into characters, characters into tokens, tokens into nodes, and nodes into another tree-like structure that is called CSS object model. Well, as I said, most of us developers, we know about DOM, we work with it. But actually, CSS object model is not something that we haven't worked with. Whenever in JavaScript we go get an element .style, background color, we're actually touching the CSS object model. We are reaching out to CSS object model. So it's not really something bizarre. But most of us don't know the name, that's all. At this stage, browser has all the information about data structure of the page and has all the information about the styling of the page. But in order to be able to render something on the screen, it needs to merge these two information. That's what happens in the next step when it generates the render tree. Render tree is another tree-like structure of all the visible elements that's supposed to be rendered on the screen. So for the next phase, browser passes the render tree to the next phase, which is called layout. At this stage, browser tries to find the geometry and coordination of each element within the viewport and basically draw some sort of a map for itself to know, OK, this element goes here and the other one goes here. Knowing all of that information, it just moves to the last step, let's say. I just oversimplified things. But it moves to the last step, and then it will paint all of that information that's coming from layout on the screen. It paints the backgrounds, it paints the border images, it paints all the styling. And then at this point, we see something on the screen in pixels. So as you can see, a browser, from the point that it receives an HTML file or CSS file to the point that actually something appears on the screen, goes through a lot of phases. But within all of these phases, there is only 2 points that us as developers have access an API. So it's only DOM and some parts of CSS object model that we can interact with and manipulate in our JavaScript code. Now, enters Houdini. Couple years ago, a group of people from W3C and web community people, they just agreed on a manifesto called Extensible Web Manifesto. In short, the main idea of this manifesto is to move the focus from providing more high-level APIs into providing more low-level APIs and expose the underlying layers. So as a result of this manifesto, a lot of changes and new APIs came into web. The name for all these new APIs in CSS world is CSS Houdini. So CSS Houdini is an umbrella term for low-level APIs. And it is going to enable us developers to have access to every phase of the rendering process. And then we can extend or change its behavior. So it has a bunch of APIs, but today we're going to talk about only 3 of them because these are the 3 that has been implemented into Blink. As a result, it is accessible in Chrome. I mean, and the time limit. So we're going to start with typed OM. Well, when we were talking about CSS object model, we said that it's a tree-like structure of all these styling. One issue with this CSS object model was that first of all, it doesn't have really great API to work with. And second of all, it is a string-based data structure. So whatever value you try to reach out in the CSS object model, it will always return a string. So typed OM is an upgraded, enhanced version of CSS object model. It will add types to CSS values in terms of JavaScript objects. And on top of that, it will provide more semantic API for us so that it will be easier to work with styling in our JavaScript code. So when previously we tried to get a styling, for example, a font size of an element with CSS object model APIs, what we would receive as a result was a 16-pixel string. And if you have ever tried to work with the styles in JavaScript, you know how messy it can get sometimes. And it's not really easy to work with. But if you try to get the same property font size using the typed OM APIs, what you will get in your console is actually an object. It is a CSS unit value object. This is the type, and it has the value and the units in separate property. It provides a set of methods that you can work with this object in your JavaScript. It's much more functional and it's easier to work with it. But typed OM is not going to improve the way that we get styles in JavaScript. It will also help us with setting styles. So as an example, I'm just going to talk about an example of when you have a box that is off-center and you want to center it using translate -15%, -15%, the thing that we always do. Remember how you should do that using the CSS object model? You have to generate a string and then pass in the x and y in. It's kind of messy, but let's see how we can do that using CSS object model. So with CSS object model, we just go ahead and say, OK, CSS, I want an x value of unit percent of -15, and then I want a y of the same type, and then create a new translate object with passing the x and y in, and then get that box that I want to set the attribute, and then set the transform, and then create a new transform value, passing that translation object that we had on top. And then with that easy, we can set transform. And it's so much more semantic. So I'm going to copy and paste it because I'm a slow typer. So bam, it works. So it is right now in Chrome, so it works. It's much more semantic and cooler if you want my opinion. So, oh yeah, that was the demo. So the next API that we're going to quickly talk about is properties and values. Before we all knew the custom property, or also known as CSS variables in CSS. And it was a really cool feature, but it has some downsides. For example, the browser didn't know how to animate these custom properties because it didn't have enough information about these properties to animate them. That's basically why usually browsers cannot animate some properties. So with the new API, which has both JavaScript and CSS syntax, first you define your CSS custom property, and then you can say what is the syntax, what is the type of value it should accept. So it can be color, it can be length, whatever CSS types that we have, and then you can say if it inherits the value, and then you can set an initial value or fallback value for this custom property. So whenever there is an error or something, browser knows what value should be replaced for this custom property. With all this information provided to the browser, now browser can transition and do animations using apply animations to these custom properties. I'm not going to go through this live code because the next part is the one that I'm really excited about, and I want to have enough time for that. So we said that in CSS Houdini, one of the promises is that they provide access to developers to different phases of rendering. So what that means is that we should be able to write a script and then pass it to the rendering engine, and the rendering engine run it on a specific rendering phase. But we cannot write those scripts in the main JavaScript body for two reasons. I mean, I didn't figure it out. The people who have been implementing it figured it out. So they figured out that it cannot be part of the main JavaScript for two reasons. First, these scripts should not have access to the DOM environment, to the document environment. Because when a rendering engine is, for example, at the layout phase, trying to create layout of the website, it assumes that DOM is not going to change. So your script should not have access to the DOM to be able to change it. A second reason is that they want these scripts to be able, I mean, they want the rendering engine to be able to run these scripts on other threads than the main threads. And they want them to be thread agnostic, so they can run on any thread if the rendering engine wants. So here comes Worklets. It's a new concept. It's very much like web workers, but it is an independent script that is run by rendering engine, and it is thread agnostic. So theoretically, the rendering engine can run them on any thread other than the main one. There are, I think Houdini has 3 worklets, Paint, animation and layout, but today we're going to talk about the paint worklet because that's the one has been implemented into Chrome. So what does paint worklet do? So when we were talking about this flow of phases of rendering, there was the last step called paint. So the paint API is going to provide access to the paint step. What happens during the paint step is that browser goes through and start painting in the background images into the elements, the border images into the borders. It starts painting into areas. So what this API enable us is to be able to do that, to paint inside elements. So how should we do it? So first, we need a paint worklet, and then we register it. I mean, we need a worklet, and then we register it as paint worklet. And then we need to add the worklet to our HTML JavaScript file. And then once we do that, in our CSS code, we can just go ahead and write background paint, and then pass the name of the paint worklet in. So what does this paint worklet that I keep repeating looks like? It's nothing complicated. It's just a simple JavaScript class that you just register as a paint worklet, and you need to set a name for it. This is the name that then we refer to the paint worklet in our CSS code. This JavaScript class is supposed to have one method, which is paint, and this paint body is where all the logic related to painting stuff goes. The first argument of the first parameter of this paint worklet is, I just named it CTX, but it's a canvas rendering context 2D. So if you have worked with canvas before, you already know how to draw stuff using this object. It is exactly the same object with the same methods, and yeah, it's simply the same one. So you can basically copy your context. If you already have a canvas, did I say context? It's canvas. So if you already have a canvas written, you can just copy and paste it with minimal changes. You already have a paint worklet. The next parameter is size. Size is the geometry of the element that we are painting in. And the third one is properties, which is, I think it's the coolest one. You can register a set of custom CSS properties or CSS variables using the static method input properties. And basically what it does is that you tell your paint worklet that, OK, there is these set of custom CSS properties that whenever I change them in my styling, I want you to repaint and regenerate the paint, whatever that you're trying to paint. And the last one is arguments, is that you can pass more than one argument to the paint function in your CSS, if you will. So yeah, it's basically it. Writing a paint worklet is, as I mentioned, it's very much like writing canvas. But what makes it super interesting is that from now on, the creative developers can generate these paint worklets and then share them as NPM packages. And then lazy developers like me, we can just go ahead and install them in our application. And as easy as that, you have new possibilities in your CSS. It's like having plugins for CSS. So let me just go and do the same thing. I don't know, you guys probably know Yuna. She is amazing, and she has so much great context, contents around CSS Houdini. And then she created this nice paint worklet that draws some scratchy lines. So I have added the CDN to this paint to my code here. And what I want to do is I have this checklist, and I want to scratch the ones that has been done. So I already added the paint worklet to my HTML file. What I need to do is to go and say background paint, and then I need to pass in the name of the worklet, which I just put it here because I have bad memory. And you see something appeared, but it's not still what we want. So we want to say, OK, I want to change the position of it to be minus 10 pixels, for example. I don't like the color, so let's change the color. There is a CSS custom property that you can set the color, so let's go ahead and do that. Oh, what did I do? Didn't I copy? Okay, now I just forgot how to copy. Okay, I'm just going to set it to dark blue. And I want to change the spread of these lines, I think. Okay, and then I want to set it to 10. And yay! You can scratch the items. And it's like a built-in CSS property. And if you're asking how do I have these lines around my box, this doodly-like lines, it's another paint worklet. So yeah. Okay, back to slides. So there are a couple of websites. These are the ones that I found. A lot of creative developers already created some examples. You can just have a look at those examples and get the idea how to write a paint worklet or use them in your applications, like I did. And then the last slide, can I use it? Well, there is a website called Is Houdini Ready Yet? And you can check this website, and it will give you all the information about how far it has been implemented into different rendering engines. And so far, Blink is ahead of everybody else. These 3 APIs that we talked about today has been implemented into Blink, so into Chrome. Actually, I mean, in the normal Chrome, you can go ahead and use them, but you should have that in mind, that it's not going to work on other browsers. So probably you need to have some sort of a fallback thingy, I don't know, something that doesn't look ugly for other people in the other browsers. But yeah, more is coming, and it's awesome. I suggest to start using them and get comfy, because I believe this is the future for us. So we get to the last slide, and thank you guys for being such an amazing audience and listening to my talk. Have fun!